Hi students, today we are going to discuss the previous year questions of JEE Mains 2024 from the chapter Thermodynamics. In the previous videos, we have discussed the same previous year questions of JEE Mains 2024 of other chapters. Hope you have seen those videos. So today we are going to the chapter Thermodynamics and we will be discussing the questions of the January attempt. So the first question. Choose the correct option for free expansion of an ideal gas under adiabatic condition from the following. So here, in this particular question, we are having two hints. One, it is free expansion. That means we know that minus P external is equal to 0. Or we can put external pressure will be 0 in the case of a free expansion. And for adiabatic condition, you know that heat transfer Q will be 0. So, we know that Q is equal to 0 for an adiabatic condition. And if Q is equal to 0, delta T will be equal to 0. That means it will be an isothermal process. There will be no change in temperature. So, we can understand delta T is also 0. And we are having the third parameter. What is that? Work done. So, what will be work done? How can you know about work done? We know that P external into delta V, right? Minus P external into delta V is what? Work done, right? Here we know that P external is what? 0. 0 into delta V is equal to what? 0. So in the sense, we will be getting work is equal to 0. So we have got Q is equal to 0, delta T is equal to 0 and W is equal to 0. So the answer will be the fourth option. Right. So, from the hints which are given in the question, what are they? An adiabatic condition and free expansion, we have concluded the answer. Right. So, I hope you have understood the thing. Now, we will be moving to the second question. In this question, we have to find out the value of delta G naught. What is that? Gibbs free energy. So we know that delta G naught is equal to minus 2.303 RT log K. Now we have the value of R, T and K given in the question. So we can substitute those values. What is R? 8.314. What is T? It is 300. And K value log this 10. So we know that log 10 is 1. Now when you solve this, minus 2.303 into 8.314 into 300, you will be getting the answer and it will be 57 into 10 raised to minus 1 kilojoule per mole. So you can do this particular calculation and you will be arriving at an answer of 57 into 10 raised to minus 1 kilojoule per mole. So here you should understand we are writing the answer in kilojoule because in the question itself it is mentioned. We have to write it in kilojoule and also we have to write it in 10 raised to minus 1. So at last, whatever the answer you get, you have to convert it into kilojoule as well as you have to write it in 10 raised to minus 1. And at last, you will be getting 57. So this was a very simple question. If you know this particular formula, delta G is equal to minus 2.303 RT log K, we can find the answer. Alright. Now we will move to the next question. If 3 moles of an ideal gas at 300 Kelvin expand isothermally from 30 dm cube to 45 dm cube against a constant opposing pressure of 80 kilopascal, then the amount of heat transferred is. So we have to find out the amount of heat transfer, that is Q. Right. So we can understand the question. It is actually an expansion of ideal gas from volume 1 to volume 2 against an external pressure, right? So here, according to first law of thermodynamics, we can write delta U is equal to Q plus W, right? So it is given, it is an isothermal process. So isothermal process means we know that delta T equal to 0, right? If delta T equal to 0, we know that delta U is equal to 0. That means we can write it as 0 is equal to Q plus W, right? Because delta U is equal to 0 in an isothermal process. So we can write Q is equal to minus W, right? Q is equal to minus W. Fine. Now, in this particular process, what is W? W is equal to minus P external into delta V, right? So here, what I can write? Here we have known Q is equal to minus W and I have W value is equal to minus P external into delta V. So I can write Q is equal to, what is Q? Minus W. So minus W value, I am taking it as minus P external into delta V, right? So I can write it as what? P external into delta V. So here, what is pressure? I will just erase this particular part. What is this particular pressure? So Q is equal to P external. So it is given as 18 kilopascal, 80 kilopascal into delta V. Delta V means V2 minus V1. So you are having 80 kilopascal into V2. 45 minus 30 dm cube, right? Now I am writing a certain relation here. That's very important to note. The same relation will be used in other questions also. So just keep this relation in your mind. The relation is that 1 Pascal is equal to 1 joule per meter cube and 1 dm cube is equal to 10 raised to minus 3 meter cube. Okay, just keep this in your mind. We are using this particular formula or this particular values in this question as well as other. So here I am putting 80 kilopascal. So kilo means it is 10 raised to 3 and Pascal I am writing it as joule per meter cube and into 45 minus 30, you know that it is 15, right? Dm cube, I am writing dm cube as into 10 raised to minus 3 meter cube. So here the meter cube and the meter cube will be cut. Here 10 raised to 3 and 10 raised to minus 3 will be going. So at last you will be having what? 18 into 15, right? 18 into 50. That means you will be having the answer as 1200 joules. Right. So here the Q value will be 1200 joules. Right. So I hope you have understood how we have arrived at the answer. First of all, we are using the first law of thermodynamics. From that, as it is an isothermal process, we are taking delta U as 0. Then from this particular given values, we are finding what is W, right? And after that, we are going to the answer of Q. Right. So I hope you understood this particular question and its answer. Right. The fourth question, and here we are actually asked to find out the equilibrium constant. Right. We have to find log K. So for this purpose, they have given temperature, enthalpy change, entropy change. Right. So with these quantities, we have to find the value of log K. So here we know that we are having Gibbs free energy formula delta G naught is equal to minus 2.303 RT log K. Here log K is coming. Now how can we relate this particular equation to delta H, delta S? So I hope you remember another equation is there for Gibbs free energy. What is that? Delta G naught is equal to delta H minus T delta S. So we can see here right hand sides can be equal as the left hand sides are equal, and we can bring a relationship between log K and this particular entropy and enthalpy change. So I am writing this particular formula as minus 2.303 RT log K equal to delta H minus T delta S. Right. So here I am just multiplying by the negative symbol. So it will be 3.303 RT log K is equal to T delta S minus delta H. Now from here I need the value of log K. So what will be log K? Log K is equal to T delta S minus delta H divided by 2.303 RT, right? So you will be getting the value of log K. So here we will just see what is actually the value. So here you will be having T delta S. So what is T? T is actually given as 400. So it is 400 into delta S. Delta S is 122. Minus delta H. Delta H is 77.2. So better I will write at the other side. So here you know what is T value. Log K is equal to, what is T value? 400 into delta S 122 minus delta H. Delta H value is given in kilojoule. So we have to do 77.2 into 10 raised to 3 because other quantities are given in joule, divided by 2.303 into R 8.314 into the temperature. What is that? 400, right? So when you solve this particular calculation, you will be getting an answer of minus 37.08 into 10 raised to minus 1, or we can just simply put it as minus 37 into 10 raised to minus 1. Okay, so this will be the value of log K, right? So you just see that here we are just substituting the values in this particular equation and you will be getting the value of log K. So once you do this calculation properly, you will be getting that particular answer and it is a straightforward question for you, right? Now we will move to the fifth question in this particular section. And you are having an easy question. Which of the following is not correct regarding Gibbs free energy change? Delta G is negative for a spontaneous reaction, right? Delta G will be always negative. We know that, we have studied that many times. Now, delta G is positive for a spontaneous reaction. If it is negative, it cannot be positive. So, obviously, this is a wrong statement, right? That is a wrong statement. And delta G is positive for a non-spontaneous reaction. It is right. Delta G value will be positive if it is spontaneous, right? So it is a true statement. So this is a true statement, this is another true statement, this is another true statement. So there is only one incorrect statement, that is the second option. What is that? Delta G is positive for a spontaneous reaction. No, it is negative for a spontaneous reaction. So our answer, which is the not correct statement, is the second one, right? Now we will move to the next question. Here it is related to the standard enthalpy of vaporization of CCl4. So they have given delta H vaporization of CCl4 is 30.5 kilojoule. It is given and it is for 1 mole. Now they have given a certain mass of this CCl4. What is that? 284 grams. For that, what is the heat required? We have to find out. Now, for that purpose, we have to write what is the given mass of CCl4. Given mass of CCl4 is 284 grams. And molar mass of CCl4. I hope you know how to find out the molar mass, right? So here carbon 12 plus chlorine 35.5 into 4. When you do this, you will be getting 154 gram per mole. Now from here, we have to find out the number of moles. So number of moles equal to what? Given mass by molar mass. So given mass is 284 divided by 154. So here you will be getting a value which will be little under 2, that is 1.8. So we are having 1.8 moles. Okay, we are having 1.8 moles of CCl4. So for 1 mole of CCl4, it is given 13.5 kJ is the delta H vaporization. Now we have to find out the delta H vaporization for 1.8 moles. So what we will be doing? We will just multiply these particular values. So here we can write delta H vaporization of 1.8 moles of CCl4 equal to what? 1.8 into 30.5, right? 1.8 into 30.5. So you will be getting the answer as 56.25 kilojoule, right? 56.25 kilojoule, right? 1.8 into 30.5. When you are doing that particular calculation, you will be getting 56.25 and that will be your answer. So it is a very easy question. The thing is that delta H vaporization for 1 mole is given and they have given a certain quantity of CCl4. We have to find how many number of moles are present. After finding number of moles, that is 1.8, you have to just multiply that value with the delta H vaporization for 1 mole and you will be getting the new heat required. So that is what? 56.25 kilojoules, right? Now, the next question, and here you are having an interesting graph. So this is actually a graph showing the work done by an ideal gas, and you can see that it is a cyclic transformation. That means the work done is actually from A to B, then to C, then to A again. So the starting point and the ending point is the A itself, right? So we can say that it is a cyclic transformation, right? So first of all, what you have to understand is that this is what P versus V graph. Here you have pressure, here you have volume. So for P versus volume or V versus P graph, area is actually what? Sorry, not area, the volume. The volume is what? Sorry, not the volume, work done. Work done is the area enclosed under the cyclic graph. That means if you want to know the work done by this particular ideal gas, you have to know the area of the cyclic graph. You know that this is the cyclic graph that we are having and it is a triangle, right? It is a triangle. So if you know the area of that triangle, you can know what is the work done. And again, if the cyclic work done is clockwise, you know that it is going in the clockwise direction, right? It is going in the clockwise direction. If it is clockwise, the work done will be positive. That means if this cyclic graph is clockwise, it will be positive. What? The work will be positive. If it was anti-clockwise, the work done will be negative. So here we will be getting a positive work. So how can you find the answer? Work is equal to area of this triangle. What is area of triangle? Half into base into height. So half, what is base here? The base is AC. AC. What is the height, altitude? AB. Right. So what I can write? W is equal to half into, what is AC? AC is actually 30 minus 10. This much part is 10. Here you have 30. So 30 minus 10. 30 minus 10. What is that? Kilopascal. Right. Into what is AB? AB is also 30 minus 10. 30 minus 10. And it is what? dm cube. dm cube. Right. Now I can write half into 20 kPa into 20 dm cube. So I hope you have remembering, I have told a relation of dm cube and Pascal. So do you remember that? What is that? 1 Pascal is equal to 1 joule per meter cube and 1 dm cube is equal to 10 raised to minus 3 meter cube. So here I am just substituting those values. 1 by 2 into 20 kilo. Kilo means it will be 10 raised to 3 Pascal. I am putting it as 1 joule per meter cube into 20 dm cube. I am putting it as 10 raised to minus 3 meter cube. So here what is happening? Meter cube and meter cube will be cut. 10 raised to 3 and 10 raised to minus 3 will be gone. So here what I have, half into 20 into 20 joules. So 20 into 20, it will be like 400, half. The answer will become 200 joules. So here we are having a easy question if you understand the concept of that particular cyclic transformation and what will be the work done when you are having a cyclic transformation, right? So I hope this is clear for you. We will move to the next question. Here, it is a quite interesting question. They have actually given 3 chemical reactions. And for the first 2 chemical reactions, they have given the delta H values. And for the third one, we have to find. Right, in the chemical reaction, in the third one, there is no delta H value, we have to find it. So we will see how to find that. So here, there is actually a relation between these 2 chemical reactions and the third. Can you observe and say that? Can you just understand what is that relation? The relation is that if you multiply with 3, this particular second reaction, I will do that. 3C it will become, and it will become 3 by 2. Right, and it will become 3CO. If you multiply with 3, so you will be getting this one. And if we subtract the first chemical reaction, we will subtract it. So you can see here minus 2Fe. Right, and minus 3 by 2 O2. Then it will be gone. 3 by 2 O2 here, minus 3 by 2 O2 there, gone. Now the right hand side. Here 3CO is there, minus Fe2O3. Right. Now you just rearrange it. Already 3C is here in this particular reaction, 3C is there. I am bringing this Fe2O3 to the left hand side. So it will become plus Fe2O3, giving you already 3CO is there, and I am just sending this 2Fe there. So it will become plus 2Fe. You can see that when you do this, 3 into the second chemical reaction minus the first chemical reaction will be giving you the third one. Is it right? So the same relation we can use for finding the value of delta H. So I can give a relation here. I am putting this third delta H as delta H3. This has delta H2. This one has delta H2 and this has delta H1. So I can write a relation delta H3 equal to 3 into delta H2 minus delta H1, right? So what is that? 3 into delta H2. What is delta H2? Minus 110. Minus of 822, right? So what is that? Minus 330 plus 822, right? So can you just find out the answer for this question? What will be the answer? It will be 492 kilojoule, right? It will be 492 kilojoule per mole. I hope I have done it right. Right, it is 492 kilojoule per mole, right? So here the trick is that the calculation part is simple. Here the logic is that if you multiply the third chemical reaction with 3 and if you subtract the first chemical reaction, you will be getting the third one. The same logic we are applying to enthalpy change and you will be getting the answer, right? Now we will move to the 9th question. Here we have to find the value of delta Rg, Gibbs free energy change. So what we will do here, we will use the same formula with some difference. What is that? Minus RT ln K. You know that 2.303 is coming when it is log. Now I am going for ln. Right, so it is Kp, right? Here the K value is Kp. Now I can just substitute the values. What is that? Minus 8.314 into T. What is T value? T value is given as 298 and Kp log natural logarithm of 2.47 into 10 raised to minus 29, right? So here students, the thing is that we need the answer in kilojoule, right? So don't forget to put this particular 10 raised to minus 3, right? Because we need the answer in kilojoule. So that's why I am multiplying here 10 raised to minus 3, 298, and you will be having this particular value as minus 65.87. Okay, minus 65.87. And at last you will be getting the value as 163 kilojoule. Right, so delta Rg in this case will become 163 kilojoule. Right, I am not focusing on the calculation, you can do it by yourself. I am just saying the methods to reach that particular last step. So here it is very obvious, delta Rg is equal to minus RT ln Kp, and we are substituting the value of RT T and Kp and finding the natural logarithm of this particular Kp value, and just you have to put that particular 10 raised to minus 3 because we need the answer in kilojoule, and you will be getting the answer as 163 kilojoule, right? Now, we will move to the last question of this particular session. Right, here we have to find out the work done for an isothermal reversible process. So, we have to find out the work done, W for isothermal reversible process. Okay, it is isothermal reversible process, the work done. So, we know that work done is equal to minus 2.303 RT log V2 by V1. So, we can substitute the values. Minus 2.303 R. What is the value of R? 8.314 into temperature. Temperature is given as 300 Kelvin and log V2. What is V2 here? V2 is given as 100 liter and V1 is given as 10. So 100 by 10. So here it will become what? Here it will become 10. So log 10 is equal to what? 1. So here minus 2.303 into 8.314 into 300. And one more thing is there, they have given 5 moles of an ideal gas. That means we have to multiply a 5 also here. So at last you will be getting an answer. You can do this particular calculation. You will be getting an answer of 28721 joules. Okay, so this will be the work done and it will be having the negative symbol, right? Already it is minus x. So the answer will be 28721 joule. So here you can do this particular calculation, but the most important thing is to know the equation for this particular isothermal reversible process. The work done is equal to minus 2.303 RT log V2 by V1, right? So by this we have come to the end of this particular video session, and here we have discussed the previous year questions of JEE Mains 2024 of the chapter Thermodynamics. In the coming video we will be seeing the second part, that is the April attempt. So watch out all the videos in our channel and just prepare for your examination. You are having 3 months for your examination, so it is the best time to start your preparation. Go through all the videos, understand the previous year questions, and confidently you move to your examination process. So thank you for watching the video. Thank you so much.